All right, ready to dive into the world of AI?
Always.
Awesome. So today we're taking a deep dive into the State of AI Report 2024. It's packed with fascinating insights into the latest advancements, emerging trends, and even some of the challenges and ethical dilemmas facing this rapidly evolving field.
It's a bit like taking a snapshot of the AI landscape, seeing where we stand today, where we're headed, and what it all means.
I like that, a snapshot of the AI landscape, and what a dynamic landscape it is. One of the things that struck me right away in this report was how the balance of power seems to be shifting, especially when it comes to those big players in the AI field.
Right. For a while there, it felt like OpenAI was miles ahead of everyone else, almost like they were playing a different game.
Exactly. Like they had cracked the code to AI dominance, no pun intended.
But this report suggests that the gap is closing. We're seeing some serious competition emerging, especially in areas like coding, which has traditionally been a stronghold for models like GPT.
Yeah, the report specifically mentioned Claude, Sonnet, Gemini, and Grok as some of the contenders that are really starting to challenge OpenAI's dominance.
It's a clear sign that the AI field is maturing. We're moving beyond those early days of one or two companies dominating the landscape to a more diverse and competitive ecosystem, which is exciting.
It's like the Wild West of AI innovation out there.
Exactly. And this competition is driving incredible progress, but it's not like OpenAI is just sitting back and watching the competition catch up. They're still pushing the boundaries in some really interesting ways, particularly when it comes to this idea of inference compute.
Inference compute. That sounds a bit technical. Can you break that down for us?
Sure. Think of it like this. Instead of just focusing on cramming more and more information into their AI models, like building a bigger brain, they're now focusing on making those models smarter at actually using that information.
So it's not just about knowing a lot of stuff, but about knowing how and when to apply that knowledge effectively.
Exactly. It's like the difference between having access to a vast library and actually knowing how to find the specific information you need to solve a problem.
Okay, that makes sense. And this is where OpenAI's latest model, O1, comes in, right?
Precisely. O1 is all about enhanced inference compute. They've poured their resources into making it incredibly good at those reasoning-heavy tasks, the ones that require the AI to connect the dots, think critically, and come up with novel solutions.
And the results. How did O1 perform?
In a word, impressive. They've made some significant strides in boosting O1's performance on those complex reasoning benchmarks.
That's what everyone wants to hear, better performance. But I'm guessing there's a trade-off here.
There always is, right? In this case, it's cost.
Okay, let's talk about the elephant in the room. How expensive are we talking?
OpenAI is very upfront about it. They acknowledge that this focus on inference compute comes at a price. Running O1 is significantly more expensive than running its predecessors, like GPT-4.
Significantly. Like how much more expensive?
Think 3 to 4 times more expensive.
Wow. Okay, that's not insignificant. So while it might be a game changer in terms of capability, it also raises some serious questions about accessibility and sustainability.
Absolutely. That's why the rise of these open models, like Meta's Llama 3 family, is generating so much buzz in the AI community.
Right, Llama 3. We've got to talk about that. It's one of the big stories in this report. For those who haven't heard, Llama 3 is this open weight language model that's been making waves, and it's shaking things up in a really interesting way.
It is. It's like the underdog that's suddenly challenging the reigning champions.
And everyone loves an underdog story, right? But what makes Llama 3 so special? Why is everyone so excited about it?
Well, for starters, it's been trained on this massive data set of text and code, something like 15 trillion tokens, which is mind-boggling.
15 trillion tokens. That's like learning from a library the size of a small planet.
Exactly. And this massive scale of training data has really paid off. Llama 3 is going head-to-head with those proprietary models from Google and OpenAI in terms of its ability to reason, handle complex language tasks, even code.
So it's not just keeping up, it's actually competing at the highest level. That's huge. But what makes Llama 3 a game changer, at least according to this report, is that it's open.
Exactly. This open weight approach is a big deal. It means that anyone can access the inner workings of the model, tinker with it, adapt it for their own purposes.
It's like opening up the hood of a high-performance car and giving everyone the tools to modify and improve it.
Exactly. And this has huge implications for innovation and accessibility. Think about all the researchers, developers, even just curious tinkerers out there who can now get their hands on this cutting-edge technology.
It's like democratizing access to the tools of AI, which could lead to a whole wave of creativity and innovation that we haven't even imagined yet.
And that's what's so exciting about this moment in AI. We're moving beyond those walled gardens, where only a few select companies had access to the most powerful tools, to a more open and collaborative ecosystem.
I love that. But before we get too carried away with the promise of open AI, the report does raise an important caveat, right? Something about the whole open label being a bit misleading in some cases.
Right. It's important to acknowledge that open doesn't always mean completely open.
Open-ish.
Exactly. There's a spectrum of openness when it comes to these AI models, and it's not always clear where a particular model falls on that spectrum.
So what should we be looking out for? How can we tell if an open model is truly open?
The report suggests asking some critical questions, like, do we have access to the model weights, the underlying code that makes the model tick? Can we see the data sets that the model was trained on, which is crucial for understanding potential biases? What about the licensing agreement? Is it truly permissive, allowing for both commercial and non-commercial use? And what about API access? Can we easily integrate the model into our own applications?
It's like checking the fine print before you sign on the dotted line.
Precisely.
Yeah.
And this push for greater transparency and accountability in AI is really important, especially as these technologies become more powerful and integrated into our lives.
Absolutely. It's not enough to just marvel at the progress.
Yeah.
We need to make sure that it benefits everyone, not just a select few. And speaking of scrutiny, the report also shines a light on some concerning issues with how we're currently measuring AI's progress, particularly in the realm of benchmarking.
Yes, benchmarking is a critical but often overlooked aspect of AI research. It's how we track progress, compare different models, and ultimately understand what these AI systems are capable of.
Right, because if we're not measuring accurately, we could be getting a false sense of progress, or worse, a false sense of security when it comes to the capabilities and limitations of these AI systems.
Exactly. And the report highlights two major problems with how we currently benchmark AI systems. The first is data contamination.
Okay, data contamination. That sounds like a serious problem. What exactly is it, and why is it such a big deal?
Imagine you're giving a student a test, but it turns out they've already seen the test questions before. Their seemingly impressive performance isn't a reflection of their actual understanding of the material, but rather a result of memorization or cheating.
Ah, so it's like AI plagiarism. These models are being tested on data that's too similar to what they were trained on, giving us this inflated sense of their abilities.
Exactly. Researchers are finding that when they test these AI models on truly novel data that's different from what they've seen before, their performance often drops significantly.
That's a bit concerning, to say the least. So it's not just about making these AI systems bigger and more powerful. It's also about ensuring that we're training and evaluating them in a way that reflects real-world performance.
Precisely. And this brings us to the second problem with AI benchmarking, errors in the benchmarks themselves.
Wait, what? The benchmarks we're using to measure AI progress are flawed.
Unfortunately, yes. The report highlights how some of the most widely used benchmarks are riddled with errors, which can skew the results and give us a misleading picture of an AI system's true capabilities.
That's a bit like trying to measure the length of something with a ruler that's been stretched or bent out of shape. You might think you're getting an accurate measurement, but in reality, it's completely off.
Exactly. And the implications of this are significant, because if we're relying on these flawed benchmarks to evaluate the safety and reliability of AI systems, we could be in for a rude awakening.
It's a sobering thought. We're putting so much faith in these AI systems to drive our cars, diagnose our illnesses, even make life or death decisions. But if the very tools we're using to evaluate them are flawed, it undermines our entire understanding of how capable and trustworthy these systems truly are.
It's a wake-up call for the AI community. We need to be much more rigorous in how we develop, evaluate, and benchmark these systems, especially as they become more powerful and integrated into our lives.
Absolutely. And this emphasis on rigor and accountability brings us to another fascinating trend highlighted in the report: the resurgence of an old friend, neurosymbolic AI.
Ah, yes. Neurosymbolic AI. It's an approach that's been around for decades, but it's recently experienced a resurgence in popularity thanks to some exciting breakthroughs and a growing recognition of the limitations of purely data-driven approaches.
Okay, for those of us who are new to this whole AI world, can you give us a quick refresher on what neurosymbolic AI is all about? What's the basic idea?
Sure, the basic idea behind neurosymbolic AI is to combine the strengths of two very different approaches to artificial intelligence. Neural networks, which excel at pattern recognition and learning from massive data sets, and symbolic reasoning, which is all about logic, rules, and abstract thinking.
So it's like combining the intuitive pattern matching abilities of a seasoned detective with the logical deductive reasoning of a master chess player.
I like that analogy. And this combination, this fusion of data-driven learning with symbolic reasoning, is proving to be particularly powerful in areas where traditional AI systems, like those based solely on neural networks, have struggled, such as math, logic, and common sense reasoning.
Right, because the real world isn't just about recognizing patterns. It's also about understanding how things work, the underlying rules and relationships that govern our world. And that's where symbolic reasoning comes in.
Exactly. And the report highlights a great example of this, alpha geometry, a neurosymbolic system developed by researchers at Google DeepMind.
Alpha geometry. Now that name rings a bell. Didn't it do something pretty impressive?
It did. Alpha geometry achieved near-human performance on Olympiad-level geometry problems, which is a really big deal.
Okay, that's impressive. Beating humans at their own game, especially when it comes to abstract reasoning and problem solving, that's no easy feat.
It's a clear sign that this hybrid approach, combining neural networks with symbolic reasoning, has the potential to unlock new levels of AI capabilities.
It's like we're finally teaching AI to think more like we do, using a combination of intuition, logic, and abstract reasoning.
Precisely. And this is just the beginning. Researchers are just starting to explore the possibilities of neurosymbolic AI, and I think we're going to see some really exciting developments in the coming years.
I'm ready for it. But speaking of exciting developments, we've got to talk about one of the most consumer-friendly trends in AI right now, bringing the power of large language models to our smartphones.
It's about time, right? Who wants to lug around a bulky computer when you can have the power of AI in your pocket?
Exactly. And it's not just about convenience. Putting AI on our smartphones opens up a whole world of possibilities for personalized on-device experiences that were simply impossible before.
Imagine AI-powered language translation that works offline, personalized education apps that adapt to your learning style in real time, or even AI-assisted creativity tools that help you write music, generate art, or brainstorm new ideas, all on your phone.
The possibilities are mind-blowing. But before we dive into the possibilities, let's talk about how they're even making this happen. I mean, these large language models are notoriously resource-intensive. How do you even begin to cram that kind of computational power into a device that fits in your pocket?
It's a huge technical challenge, but the report highlights some really clever techniques that researchers are using to shrink down these models without sacrificing too much performance. One approach is simply to build smaller models from the ground up, specifically designed for mobile devices.
So instead of trying to shrink a giant down to size,
Yeah.
they're creating something new that's specifically designed for a smaller footprint.
Exactly. And the results are quite impressive. The report mentioned Microsoft's Phi 3.5 mini model, which, despite its small size, is achieving surprisingly good performance on tasks like reasoning and question answering, even rivaling some of the larger models out there.
That's amazing. It's like those tiny house movement, where people are finding creative ways to live comfortably and efficiently in smaller spaces. But instead of houses, we're talking about AI models.
Exactly. And then there's Hugging Face, another big name in the AI world, who are taking a slightly different approach with their small m family of models.
Small LM. The name alone is adorable. Are these like the teacup puppies of the AI world?
Kind of. They're specifically designed to be small and efficient, but they're still surprisingly capable. They might not be able to do everything that their larger counterparts can do, but they excel at specific tasks.
It's all about finding the right tool for the job. And sometimes the most efficient tool isn't always the biggest or the most complex.
Precisely. And this focus on efficiency is only going to become more important as we seek to deploy AI in more and more resource-constrained environments, like smartphones, wearables, and even tiny sensors embedded in our surroundings.
It's like we're entering a new era of AI, one where it's not just about raw power and performance, but also about efficiency, accessibility, and making sure that these technologies are available to everyone.
And that brings us to another really interesting technique that's highlighted in the report, distillation.
Distillation. That sounds intriguing. What is that all about?
Imagine a master chef who's spent years honing their skills and perfecting their recipes. Now imagine that chef teaching a promising young cook how to recreate those same dishes, not by simply handing over the recipes, but by sharing their knowledge, their techniques, their intuition.
So it's like transferring the essence of their culinary expertise rather than just the raw ingredients and instructions.
Exactly. And that's essentially what distillation is in the world of AI. It's about taking a larger, more complex AI model, the master chef in our analogy, and using it to train a smaller, more efficient model, the promising young cook.
Okay, I'm liking this analogy. So the smaller model is essentially learning from the best, benefiting from the knowledge and experience of its larger counterpart without needing all the same computational resources.
Precisely. And this approach is proving to be surprisingly effective. The report mentioned that Google is using this technique with their Gemini family of models, creating smaller flash versions of their larger Pro models.
So they're like the streamlined, lightweight versions of those high-performance models, designed for speed and efficiency. And they're actually managing to achieve comparable results, even with a smaller footprint.
It's quite remarkable. They've even had success using distillation to create remarkably efficient text-to-image models, which are notoriously resource-intensive.
That's amazing. It really highlights how we're constantly finding new and innovative ways to make AI more accessible, more efficient, and ultimately more useful in our everyday lives.
And it's not just happening in Silicon Valley. The report highlighted some impressive progress being made in other parts of the world, like China, despite facing some significant challenges.
Right. I was really struck by that section of the report. It's easy to get caught up in the narrative of Silicon Valley being the epicenter of all things AI, but the reality is much more complex and nuanced.
Absolutely. And China is a perfect example of this. Despite facing sanctions that limit their access to high-end chips and technologies, Chinese companies and research labs are still making incredible strides in the field of AI.
It's a testament to the ingenuity and determination of the researchers and engineers working on these projects, finding creative ways to overcome obstacles and push the boundaries of what's possible.
Exactly. And it highlights how the future of AI is not going to be shaped by any one country or region, but by a global community of researchers, developers, and entrepreneurs all working towards a common goal.
I love that. It's a global endeavor, a collective effort to unlock the potential of this incredible technology. So what are some of the ways that Chinese companies and research labs are making their mark on the AI landscape? What are they doing differently?
Well, for starters, they're not afraid to think big and be bold in their ambitions. The report mentioned companies like DeepSeek and O1 Toward AI, who are developing their own large language models that are going head-to-head with those from the biggest names in the industry.
They're not just trying to catch up, they're aiming to lead. I like their ambition.
And they're not just focusing on building bigger and better models, they're also innovating in areas like computational efficiency, recognizing that not everyone has access to unlimited computing resources. They're also building their own large language data sets, which is crucial for training these models and ensuring that they reflect the nuances and complexities of different languages and cultures.
It's like they're building their own AI ecosystem from the ground up, and it's really impressive to see.
It is. And this rise of multiple centers of AI innovation around the world is something to be celebrated. It brings diversity of thought, different approaches to problem solving, and a healthy dose of competition, which ultimately benefits everyone.
Absolutely. And speaking of competition, we can't talk about AI hardware without mentioning the 800-pound gorilla in the room, NVIDIA.
Yeah.
They're still the dominant force, right?
Without a doubt, NVIDIA continues to reign supreme in the AI hardware arena. Their GPUs are the gold standard for AI training and inference, and they've built a formidable lead in this rapidly growing market.
So, are they invincible? Is NVIDIA destined to rule the AI hardware world forever?
Well, that's the million-dollar question, isn't it? And the report suggests that while NVIDIA is currently in a very strong position, their dominance might not be as absolute as it seems.
Ooh, intrigue. Tell me more. What are the potential cracks in NVIDIA's armor?
For one, the global chip shortage that's been plaguing the tech industry for the past few years is finally starting to ease. This means that NVIDIA is facing increased competition from other chip makers who are eager to get in on the lucrative AI action.
So more competition on the horizon. That's good news for consumers, right? More options, potentially lower prices. It's all good, right?
Absolutely. And it's not just about established players like AMD and Intel. We're also seeing a surge of innovative startups emerging, each with their own unique approach to AI hardware. Some are focusing on specialized chips designed for specific AI tasks, while others are exploring completely new architectures that challenge the traditional approach to computing.
It sounds like the AI hardware landscape is about to get a whole lot more interesting. But even with all this innovation and competition, NVIDIA is still a formidable force, right?
Absolutely. They've got a massive head start, a war chest of cash, and a reputation for building some of the most powerful and reliable AI chips on the market.
So it's going to take more than just a few scrappy startups to dethrone them. But I'm sensing that there are other factors at play here too. What else is potentially chipping away at NVIDIA's dominance?
One interesting trend is the growing interest in custom AI chips, specifically designed for specific applications or even specific companies.
So instead of using general-purpose chips, companies are starting to build their own chips tailored to their specific needs.
Exactly. And this is being driven by a few factors. First, custom chips can be optimized for specific AI workloads, which can lead to significant performance gains and efficiency improvements. Second, custom chips can give companies greater control over their supply chains, which is becoming increasingly important in a world where chip shortages can disrupt entire industries. And finally, custom chips can provide a competitive advantage, allowing companies to differentiate themselves and build products and services that are simply impossible to replicate with off-the-shelf hardware.
So it's like the difference between buying a suit off the rack and having one custom tailored to your exact measurements and style.
Perfect analogy. And some of the biggest names in tech are already going down this path. Google, for example, has developed their own custom AI chips called Tensor Processing Units, or TPUs, which they use to power everything from Google Search to their AI-powered cloud services.
Okay, that makes sense for a company like Google. They've got the resources and the expertise to pull off something like that. But what about smaller companies? Can they afford to develop their own custom AI chips?
It's definitely a significant investment, but it's becoming increasingly accessible thanks to the rise of specialized chip design companies and the growing ecosystem of open source hardware and software tools.
It's like the democratization of chip design. I love it.
Exactly. And even companies that don't want to go through the hassle of designing their own chips from scratch can still benefit from this trend towards customization. They can partner with companies like Cerebras and Grok, who are building specialized AI hardware platforms designed for specific use cases.
It's fascinating to see how this hardware arms race is shaping the future of AI. But before we get too caught up in the silicon and transistors, let's take a step back and remember that AI is ultimately about much more than just hardware and algorithms. It's about using these tools to solve real-world problems and improve people's lives.
Absolutely. And while we've made incredible progress in recent years, there's still so much we don't know about AI, especially when it comes to replicating some of the most fundamental aspects of human intelligence.
Like what? What are some of the areas where AI still struggles? What are those grand challenges that researchers are grappling with?
Well, one area that continues to baffle AI researchers is something that seems incredibly intuitive to us humans: planning and simulation, particularly when it comes to understanding cause and effect.
Okay, hold on. We're talking about AI systems that can write poetry, compose music, even beat grandmasters at chess, but they struggle with understanding something as basic as cause and effect.
It might sound surprising, but it's true. Even the most advanced AI systems still have trouble grasping the idea that actions have consequences, that one event can lead to another, and that the world doesn't just reset itself after every interaction.
So like understanding that if you knock over a glass of water, it's going to spill everywhere. Basic physics.
Exactly. And while that might seem like a trivial example, this inability to fully grasp cause and effect has huge implications for things like self-driving cars, robots that interact with the physical world, and even AI systems designed to make decisions in complex, dynamic environments like finance or healthcare.
It makes you appreciate just how complex our own brains are, doesn't it? We take these things for granted, but for AI, it's still a major hurdle. So how are researchers even beginning to tackle this problem? Are there any promising avenues they're exploring?
There are. One technique that's showing some promise is something called Monte Carlo tree search, or MCTS.
Okay, MCTS. I'm intrigued. Break it down for us. How does it work?
Imagine an AI looking ahead into the future, exploring a vast number of possible scenarios and their potential outcomes, all in the blink of an eye. It's like having a superpowered chess player who can visualize thousands of moves ahead.
Whoa. So instead of just reacting to the current situation, the AI is actually thinking strategically, weighing the potential consequences of its actions before making a move.
Exactly. And by simulating these different scenarios, the AI learns to make better decisions, choosing the path that's most likely to lead to the desired outcome.
So it's like learning through trial and error, but in a virtual space where mistakes don't have real-world consequences. That's pretty clever. And this MCTS technique, it's not just limited to games, right? You mentioned that researchers are finding ways to apply it to real-world problems too.
Exactly. They're exploring ways to use MCTS to train robots to navigate complex environments, to help self-driving cars anticipate and respond to unexpected situations, even to improve the planning and reasoning abilities of language models.
That's incredible. It's like giving AI a crash course in strategic thinking, helping them to see beyond the immediate situation and consider the long-term consequences of their actions. But even with these advancements, the report made it clear that there's still a long way to go. We're not going to have AI masterminds running the world anytime soon, right?
Not quite. Even with MCTS and other cutting-edge techniques, those large language models, or LLMs as they're often called, are still limited by their core programming. They're incredibly good at what they do, whether it's generating text, translating languages, or writing code, but they can sometimes get so caught up in the details that they miss the bigger picture.
So they're like that friend who's great at following a recipe step by step, but can't quite grasp the concept of improvisation in the kitchen.
A perfect analogy. And this narrow focus can sometimes hinder their ability to come up with truly creative or innovative solutions, the kind that require thinking outside the box, so to speak.
So how do we get them to think outside the recipe book? How do we encourage more creative problem solving in AI?
That's the million-dollar question, and it's something that researchers are actively exploring. One promising avenue is to use LLMs to actually generate their own internal reasoning processes.
Wait, so the AI is learning to think about how it thinks. That's getting meta.
It is. It's like giving the AI the tools and techniques to analyze its own thought processes, identify potential flaws, and refine its reasoning abilities over time.
That's fascinating. So instead of just spitting out answers, these AI systems are starting to engage in a deeper level of metacognition, becoming more aware of their own strengths and limitations.
Precisely. And this self-awareness, this ability to reflect on their own thinking, is seen as a crucial step towards developing more robust, reliable, and ultimately trustworthy AI systems.
It's like AI is entering a new stage of development, one where it's not just about mimicking human intelligence, but about developing its own unique form of intelligence, complete with introspection and self-awareness.
And that's what makes this field so incredibly exciting. We're witnessing the birth of something truly new and potentially transformative.
Absolutely. But for now, let's take a quick break and come back to explore some of the other fascinating areas of AI research and development, from the world of robotics to the ethical considerations we need to be mindful of as these technologies continue to evolve.
It's like we're on the verge of AI having those aha moments, those flashes of insight that lead to creative breakthroughs.
Right, and we often take those moments for granted, but they're actually incredibly complex. It's not just about processing information, it's about making connections, seeing patterns, and generating new ideas. And the fact that researchers are even attempting to replicate this in AI is mind-boggling.
It is, and it's leading to some really fascinating research. One example that stood out in the report is Quiet Star.
Quiet Star, okay, refresh my memory. What's that one all about?
It's a system developed by researchers at Stanford and Not Bad AI, and it's all about training AI models to generate their own internal rationale for the decisions they make.
So instead of just spitting out an answer, the AI can now explain its thought process, like showing its work on a math problem.
Exactly. And this transparency is huge, not just for understanding how the AI arrived at a particular conclusion, but also for identifying potential biases or flaws in its reasoning.
It's like giving the AI a voice, allowing it to articulate its thought process and engage in a more meaningful dialogue with humans.
Precisely. And that's incredibly important as these AI systems become more integrated into our lives. We need to be able to trust their judgment, and that trust is built on transparency and understanding.
Absolutely. But the report also highlighted that sometimes bigger isn't always better in the AI world. There's this intriguing idea of strategically allocating computational power during the decision-making process, even if it means using a smaller, more efficient model overall.
Yes. It's like giving the AI a temporary boost of brain power just when it needs it most, kind of like those energy drinks that promise to sharpen your focus for a short burst of time.
So instead of running a massive AI model all the time, which can be incredibly energy intensive and expensive, you strategically allocate those resources at crucial moments, like when the AI is faced with a particularly challenging task or decision.
Exactly. It's about working smarter, not just harder.
I like that. And this approach seems to be challenging some of the conventional wisdom in AI, which is often focused on building ever larger and more complex models.
It is. It's forcing us to rethink our assumptions about the relationship between model size and performance.
It's like in those sports movies, where the underdog team realizes they don't need to be the biggest or the strongest to win, they just need to outsmart their opponents.
I love it.
Love it. And speaking of outsmarting the competition, the report also delves into a concept that's been a holy grail for AI researchers for decades: open-endedness.
Open-endedness. Okay, that one sounds intriguing. What's that all about?
In the simplest terms, open-endedness refers to the ability of an AI system to go beyond pre-programmed tasks and actually generate new knowledge, discover novel solutions, and adapt to constantly changing environments.
So it's like the difference between an AI that can play chess by following a set of rules and an AI that can invent a whole new game with its own rules and strategies. Exactly. It's about moving beyond mimicry, beyond simply replicating human intelligence, towards a more fundamental form of creativity, curiosity, and adaptability.
That's a tall order. And how are researchers even approaching this concept of open-endedness in AI? What are the tools and techniques they're using?
It's a multifaceted challenge, but the report highlights several promising avenues of research, including things like reinforcement learning, where AI agents learn through trial and error, much like how humans learn.
Right. So instead of just being told what to do, these AI systems are actually learning from experience, experimenting, making mistakes, and refining their strategies over time.
Exactly. And it's not just about individual learning. There's also a lot of interesting work being done on things like self-improvement, where AI systems are designed to constantly analyze and refine their own algorithms, essentially becoming their own teachers.
So it's like AI systems that are constantly learning, adapting, and evolving all on their own. It's like something out of a science fiction novel, but it's actually happening.
It is. And then there's this fascinating area of research focused on evolutionary algorithms, which take inspiration from the process of natural selection to optimize AI systems over time.
Okay, evolutionary algorithms, that sounds intense. How does that work?
Essentially, you create a population of different AI agents, each with its own unique set of algorithms or parameters. You then let them loose on a particular task or problem, and the ones that perform the best are allowed to reproduce, essentially passing on their successful traits to the next generation of AI agents.
So it's like survival of the fittest, but in the world of algorithms and data.
Exactly. And over many generations, this process can lead to the emergence of incredibly sophisticated and effective AI systems, often in ways that would have been impossible to predict or design by human engineers.
It's like we're giving AI the tools to evolve and adapt on its own, much like life on Earth has done for billions of years.
Yeah.
It's both exhilarating and a little bit unnerving at the same time.
It is. But it's also incredibly exciting. We're just beginning to explore the possibilities of open-ended AI, and the potential for breakthroughs is enormous.
The report mentioned a project called Strategist. What's that all about?
Ah, yes. Strategist is a fascinating project by Google DeepMind, where they're essentially training AI systems to play these incredibly complex strategy games.
Okay, I'm guessing these aren't your typical board games like checkers or chess. What kind of games are we talking about here?
Think more along the lines of those massively multiplayer online games, like StarCraft or Dota 2, where you have multiple players, complex economies, and thousands of variables to consider at any given moment.
Wow, those games require some serious strategic thinking and planning.
Exactly. And what's so exciting about Strategist is that these AI agents aren't just playing by the rules of the game, they're actually learning, adapting, and developing their own strategies through gameplay.
So it's like watching a group of brilliant strategists play a game of chess. But in this case, the strategists are AI agents, and the chessboard is a virtual world with endless possibilities.
That's a great analogy. And the really exciting thing is that these AI agents are starting to outperform not just other AI systems, but also seasoned human players.
Wow.
Oh.
So they're not just playing the game, they're actually starting to master it in a way that rivals human intelligence and strategic thinking. That's incredible.
It is. And it makes you wonder, if AI can achieve this level of mastery in a controlled game environment, what possibilities might open up when we apply these same principles to real-world challenges?
Right. It's like we're training AI to think strategically and solve problems in ways that we haven't even imagined yet. It's both exciting and a little bit daunting at the same time.
Absolutely. But let's shift gears for a moment and talk about another area where AI is making incredible strides: robotics.
Yes, robotics. It's one of those fields where science fiction has always felt tantalizingly close to reality, and now, thanks to AI, it feels like we're finally crossing that threshold.
Exactly. And one of the biggest breakthroughs in recent years has been the application of large language models, or LLMs, and vision language models, or VLMs, to robotics.
Okay, I think we touched on these models earlier, but remind me again, what are they all about, and how are they being used in robotics?
Sure. So LLMs are essentially AI systems that excel at understanding and generating human language. Their what powers things like chatbots, language translation tools, and even those AI-powered writing assistants.
Right, like the ones that can write emails and essays for them.
Exactly. VLMs, on the other hand, are designed to understand and interpret both visual and linguistic information. They can analyze images, understand captions, and even generate descriptions of what they see.
So they're like the AI equivalent of those people who can effortlessly switch between reading a book and watching a movie, seamlessly integrating information from different sources.
Exactly. And by combining these two types of models, LLMs and VLMs, researchers are essentially giving robots a massive brain boost, allowing them to process information, make decisions, and interact with the world in a way that's more similar to how humans do it.
So it's like we're finally bridging that gap between the physical dexterity of robots and the cognitive abilities of AI.
Precisely. And this is leading to some truly remarkable advancements in robotics. From making robots more adaptable and robust to real-world environments, to enabling them to perform more complex and nuanced tasks.
It's like we're finally moving beyond those clunky pre-programmed robots of the past and into a new era of intelligent, adaptable machines that can work alongside humans in all sorts of settings.
Exactly. And one of the most interesting developments in this area is OpenAI's renewed interest in robotics after they disbanded their robotics team a few years back.
Oh, right. I remember that caused quite a stir at the time. So what changed their minds? Why are they back in the robotics game?
It seems they've recognized the incredible potential of these foundation models, those LLMs and VLMs we were just talking about, to revolutionize robotics.
So instead of building robots from the ground up, they're now focusing on developing the AI brains that will power the next generation of robots.
Exactly. And they're not alone. The report highlights a surge of interest in this approach across the field of robotics. Researchers are realizing that these foundation models can help to overcome some of the long-standing challenges in robotics, like the need for massive amounts of data to train robots for specific tasks and the difficulty of designing robots that can interact with the real world in a safe and reliable way.
It's amazing to think that these same AI systems that can write poetry and compose music can also be used to teach robots how to grasp objects, navigate obstacles, and even understand human intentions.
It's a testament to the incredible versatility of these AI systems.
Yeah.
And the applications in robotics are only just beginning to be explored.
I'm excited to see where this leads. What are some of the specific areas where we're seeing the biggest advancements in AI-powered robotics?
One area that's particularly exciting is in making robots more robust to the inherent uncertainty and variability of the real world.
Right, because let's face it, the real world rarely unfolds exactly according to plan. There are always unexpected obstacles, changing conditions, and unforeseen events that can throw a wrench into even the most carefully laid plans. And for robots, which have traditionally struggled with anything outside of their pre-programmed routines, this can be a major challenge.
Exactly. But thanks to AI, we're starting to see some real progress in this area. The report highlights a system called DIGGR-L, which stands for Digital Reinforcement Learning.
Okay, Digger. I'm intrigued. Tell me more.
So DIGGR-L is specifically designed for robots operating in real-world settings where they need to be able to adapt to changing conditions and learn from their experiences.
And how does it work? What makes DIGGR-L so special?
It's all about giving robots the ability to learn from their mistakes and improve their performance over time, much like how humans learn. Imagine a robot trying to navigate a crowded room. With DIGGR-L, the robot can experiment with different paths, learn from its collisions and near misses, and gradually develop a more sophisticated understanding of how to navigate that specific environment.
So it's like giving the robot a crash course in real-world experience, but in a safe and controlled way.
Exactly. And what's really interesting about DIGGR-L is that it's not just limited to physical robots navigating physical spaces. It's also being used to train robots that can interact with the digital world.
Wait, robots interacting with the digital world? What does that even look like?
Think about all those tasks that we do on our computers and smartphones every day. Browsing the web, checking email, filling out forms, even playing games. These are all tasks that DIGGR-L is being used to train robots to do.
So we're not just talking about robots that can move around in the real world. We're talking about robots that can navigate the digital world just as effectively.
Precisely. And this is becoming increasingly important as our lives become more intertwined with the digital realm. We need robots that can seamlessly navigate both the physical and digital worlds, and Diggerel is a big step in that direction.
It's like we're witnessing the emergence of a new breed of robots, one that's as comfortable navigating a spreadsheet as it is navigating a crowded room.
Exactly. And it's not just about making robots more adaptable and robust. Another major trend highlighted in the report is the increasing use of multimodal data in robotics.
Multimodal data. Okay, remind me again, what does that mean?
Traditionally, robots have relied on a single sensory input like vision or touch to understand their environment.
So they've been a bit like us trying to navigate the world with our eyes closed or our hands tied behind our backs.
Exactly. But now, thanks to AI, we're developing robots that can seamlessly integrate information from multiple sources, visual, linguistic, even sensory data, to build a much richer and more nuanced understanding of the world around them.
So it's like giving robots the ability to experience the world more like humans do, using all of their senses to create a more complete and dynamic picture of their surroundings.
Precisely. And one of the most compelling examples of this is Wave's Lingo 2, a cutting-edge vision-language action model that's changing the game in self-driving cars.
Okay, Lingo 2. That name rings a bell. Remind me what makes it so special.
Well, unlike most self-driving systems, which operate as kind of a black box where it's difficult to understand their decision-making process, Lingo 2 can actually explain its actions in real time using natural language.
So it's like having a self-driving car that can tell you exactly what it's thinking and why it's making certain decisions. That's incredible.
It is. And it's not just about satisfying our curiosity. This ability to link language explanations directly to decision-making has huge implications for building trust in autonomous systems.
Right, because trust is going to be essential as we increasingly rely on AI-powered systems to make decisions that impact our safety and well-being. If we can understand how these systems think, we're more likely to trust their judgment.
Exactly. And it's not just about self-driving cars. This ability to generate natural language explanations has implications for all sorts of AI-powered systems, from medical diagnosis tools to financial trading algorithms.
It's like we're giving these AI systems a voice, allowing them to communicate their thought processes and build trust with humans.
Precisely. And speaking of self-driving cars, the report also highlighted another game-changing development in that field. Prism One, also from Wave.
Okay, Prism One. What's so special about this one?
Well, Prism One is all about making it easier, faster, and cheaper to develop and test self-driving systems, all thanks to the power of generative AI.
Generative AI. That's a hot topic these days. And we've talked about it a bit in the context of creating realistic images and videos, but how is it being applied to self-driving cars?
Well, one of the biggest challenges in developing self-driving cars is the need for massive amounts of data to train these systems. They need to see millions, if not billions, of miles of real-world driving in order to learn how to navigate safely and reliably.
Right, because the real world is full of surprises,
Right.
and you can't always predict what's going to happen next on the road.
Exactly, and that's where Prism One comes in. It's a generative model that can create incredibly realistic simulations of driving scenarios, all from simple camera inputs.
So instead of sending out fleets of cars to collect real-world driving data, which can be expensive, time-consuming, and even dangerous, you can now use Prism One to generate that data virtually.
Precisely. And these aren't just crude simulations. Prism One creates incredibly detailed and realistic recreations of urban environments, complete with moving vehicles, pedestrians, cyclists, even changing weather conditions.
It's like having a virtual city at your fingertips, where you can test out different driving scenarios, train your self-driving algorithms, and identify potential problems, all without ever putting a real car on the road.
Exactly. And because Prism One uses only camera inputs, which are relatively inexpensive and readily available, it has the potential to dramatically reduce the cost and complexity of developing and testing self-driving systems.
That's huge. It could democratize access to this technology, allowing smaller companies and research groups to compete on a more level playing field with those industry giants.
Exactly. And this is just one example of how generative AI is being used to accelerate progress in robotics. Another really interesting application is in the area of robot control and decision-making.
Okay, I'm intrigued. Tell me more about how generative AI is being used to make robots smarter and more capable.
Well, one approach that's showing a lot of promise is the use of diffusion models.
Diffusion models. I think we touched on those earlier when we were talking about realistic image generation. But remind me, how do they work and how are they being applied to robotics?
Right, so diffusion models are a type of generative AI that excel at modeling complex multidimensional data. They've already revolutionized the way we generate images, videos, and audio, and now researchers are finding clever ways to apply them to robotics.
Okay, so instead of generating realistic-looking pictures or sounds, we're now using these diffusion models to generate actions and movements for robots. How does that work?
It's actually quite ingenious. Imagine a robot trying to grasp a delicate object like an egg. It needs to understand not just the shape and texture of the egg, but also the spatial relationships between its own movements and the object itself, so it doesn't crush the egg.
Right, so it's a delicate dance between perception, planning, and precise control.
Exactly. And this is where diffusion models shine. They excel at capturing those complex, nuanced relationships between a robot's actions and the environment, essentially allowing the robot to model the physics of the world in a much more sophisticated way than traditional approaches.
So these diffusion models are giving robots a deeper understanding of cause and effect, allowing them to move through the world with more grace, precision, and intelligence.
Precisely. And it's not just about making robots more graceful, it's also about making them more adaptable and resilient in real-world environments.
Right, because the real world is full of surprises. A robot that can only operate in a perfectly controlled lab environment isn't going to be very useful in our messy, unpredictable world.
Exactly. And that's why this research on diffusion models in robotics is so exciting. It has the potential to make robots more useful, more versatile, and ultimately more integrated into our lives.
It's like we're teaching robots to move through the world with the same kind of fluidity and adaptability that we humans take for granted. And that opens up a whole world of possibilities.
Absolutely. And speaking of possibilities, the report highlighted some fascinating ways that researchers are finding to stretch existing real-world robotics data further than we currently do, kind of like getting more bang for our buck with the data we've already collected.
So it's like data recycling for robots. I like it. Tell me more. How are they doing that?
One really clever approach involves extracting more affordance information from human video data.
Affordance. Okay, that's a new one for me. What does that mean in the context of robotics?
In essence, affordance refers to the possibilities for action that an object or environment offers. For example, a chair affords sitting, a door affords opening, a button affords pushing. It's about understanding the inherent functionality of things based on their physical properties and how we typically interact with them.
So it's like having an intuitive sense of how things work, even if we've never encountered that specific object before. We just kind of get it based on our past experiences and our understanding of the physical world.
Exactly. And what researchers are finding is that they can actually extract valuable information about these affordances by analyzing vast amounts of human video data.
Okay, so instead of just showing robots how to perform specific tasks like picking up a cup or opening a door, we can now show them thousands of hours of human videos and let them figure out the underlying principles of how objects and environments work.
Precisely. And this affordance learning, as it's often called, is proving to be a powerful technique for enhancing robot perception and control.
It's like giving robots a crash course in common sense physics, helping them to understand not just what things are, but also how they work and how to interact with them.
Exactly. And this focus on affordance learning is just one example of how researchers are finding creative ways to extract more value from existing data. Another interesting approach is the use of chain of thought reasoning.
Chain of thought reasoning. Didn't we talk about that earlier in the context of language models?
We did, and it turns out that this technique, which involves training AI systems to break down complex tasks into smaller, more manageable steps, is also incredibly useful in robotics.
So instead of just giving a robot a command, like, make me a cup of tea, you can now break that down into a series of smaller steps, like grab the kettle, fill it with water, place it on the stove, and so on.
Exactly. And by training robots to think in this step-by-step manner, researchers are finding that they're able to perform more complex tasks, adapt to unexpected situations, and even learn new skills more quickly.
It's like we're giving robots the ability to plan and problem solve, more like humans do, thinking through the steps involved in a task and anticipating potential challenges before they arise.
Precisely. And this ability to think more strategically and adapt to changing circumstances is going to be crucial as we increasingly rely on robots to work alongside humans in all sorts of settings.
It's like we're moving beyond the era of robots as simple tools and into an era of robots as partners and collaborators.
Exactly. But as with any powerful technology, it's important to consider the ethical implications of these advancements. We need to make sure that we're developing these technologies responsibly with a focus on safety, fairness, and transparency.
Absolutely. We need to make sure that these technologies are used to benefit humanity, not harm it. And one area where these ethical considerations are particularly important is in the field of medicine.
Absolutely. AI has the potential to revolutionize healthcare, but we need to proceed with caution and ensure that these technologies are developed and used in a way that benefits everyone. And the State of AI report delves into some of these ethical considerations in detail.
It's a topic that deserves its own deep dive, wouldn't you say?
Absolutely.
Okay, so we've got this fascinating world of AI hardware with all these different players vying for a piece of the pie. You mentioned companies like Cerebras and Grok who are taking on the mighty NVIDIA. What's their secret sauce? How are they even hoping to compete?
Well, both Cerebras and Grok are kind of like those niche boutiques that offer something truly unique and specialized, catering to a specific clientele. They're not trying to be everything to everyone. They're focusing on what they do best.
So it's like that old saying, the riches are in the niches.
Exactly. And in Cerebras' case, their niche is building massive wafer-scale AI chips. They've created this thing called the wafer-scale engine, which is essentially an entire supercomputer crammed onto a single chip.
Whoa, a whole supercomputer on a chip. That sounds like something straight out of a science fiction movie.
It kind of is. It's a radical departure from the traditional approach of connecting multiple smaller chips together.
So instead of building a city with lots of separate buildings, they're building a single massive structure that houses everything.
That's a great way to think about it. And this approach has some real advantages, particularly when it comes to speed and efficiency.
Right, because in the world of AI, speed is everything. Everyone's trying to train those models faster, run those algorithms faster, get those insights faster.
Exactly. And Cerebras is playing right into that demand. Their wafer-scale engine is designed to dramatically accelerate the training of large language models, which are some of the most computationally intensive tasks in AI.
So who are they targeting with this superpowered chip?
They've had a lot of success attracting customers in industries that deal with massive amounts of data, like energy, pharmaceuticals, and finance. These are companies that are always looking for ways to speed up their research and development, and Cerebras technology is a perfect fit.
It's like giving them a turbo boost for their AI projects. And what about Grok? What's their unique selling proposition?
Grok is taking a different approach. Instead of trying to compete with NVIDIA on raw processing power, they're focusing specifically on AI inference.
Right, inference. That's the process of actually using a trained AI model to make predictions or perform tasks, as opposed to the training phase.
Exactly. And it's a massive market because once you've trained an AI model, you need a way to deploy it and put it to work in the real world, whether that's on a smartphone, in a data center, or even in a self-driving car.
So Grok is essentially saying, hey, NVIDIA might be great at training those models, but we're the experts at making them work in the real world.
Precisely. And they're backing up that claim with some impressive technology. Their chips are designed specifically for AI inference, which means they can deliver incredible performance and efficiency for those real-world applications.
It's like they built a custom engine specifically designed for the AI inference racetrack.
Exactly. And they've been racking up some impressive wins, securing partnerships with big names like Aramco, Samsung, and even Meta.
So they're definitely a company to watch. But I'm curious, both Cerebras and Grok are facing some stiff competition, not just from NVIDIA, but also from those cloud giants like Amazon, Google, and Microsoft, who have their own massive AI infrastructure and are constantly expanding their offerings.
You're absolutely right. It's a tough market to crack. But both Cerebras and Grok are bringing something unique to the table, and they're attracting a lot of interest from companies who are looking for alternatives to the status quo.
It's exciting to see so much innovation and competition in this space. It's like the Cambrian explosion of AI hardware, with all these different species evolving and adapting to fill different niches.
It is, and ultimately it's the end users, the people who are actually using these AI technologies, who benefit from this diversity and competition.
Absolutely. More options, lower prices, better performance. It's a win-win for everyone.
Well, I think that's a great place to wrap things up. We've covered a lot of ground today, from the latest research breakthroughs to the ethical considerations surrounding AI to the business landscape and the race for AI hardware dominance.
It's been a fascinating journey. And it's clear that we're just at the beginning of the AI revolution. The possibilities are truly endless, and I'm excited to see what the future holds.
Me too. And to our listeners, we hope you've enjoyed this deep dive into the world of AI. It's a complex and rapidly evolving field, but it's also incredibly exciting and full of potential. So stay curious, stay informed, and let's build a future where AI empowers us all.